In this brief video, we'll develop the tools to know what the power and energy in capacitors are. This is a relatively important thing to do because capacitors store energy, so knowing how they interact with that energy is very important. Recall that the power as a function of time is V of t times I of t. But we know from the last video that I of t is C dV dt. So, power as a function of time, if I sub this in here, is going to be C times V times dV dt. Usually, we don't really care too much about the power when we're dealing with DC circuits, but we can use the power to get the energy. Energy is really what we're looking for in a capacitor. And it's the integral of the power. Now, if this is true, and we plug in this expression for power, then we get the integral from t0 to t of CV dV dt times dt, or CV dV. Since we're integrating this with respect to voltage now and not time, we have to remember that our bounds change. And this ends up giving us the expression 1/2 CV squared. This is the fundamental expression for energy in a capacitor. The unit is still joules. One last thing, if you remember that by the definition of the capacitor, Q is actually given as V over C, my apologies, V times C, then our energy equation could also be written as 1/2 times Q squared over C. These expressions tell us how much energy is stored, and therefore how much work we can do once we've charged up the capacitor.